Silent. Yeah, we're live. It is 7:14. 14. That's right. That's close. That's close to 7. Tonight we want to talk about a couple things. Actually, originally what I was wanting to talk about, and now we've already kind of faded out here just a little bit. Oh, it's like magic. What I wanted to talk about tonight originally was the tool. I have a thumbnail up on our damper removal tool for LS application. So when you're doing a cam change, you have to take off the damper to get front cover off, to get the cam out. So if you're doing a cam swap, you got to do that. This tool, very affordable, because that's what we're trying to do. Is we're trying to get, we're trying to make performance affordable again. So after you remove the bolt, then this tool allows you to go in with the right size. These are essentially push rods, basically, and then it's a threaded 3-jaw, and the push rod goes into a receiver in the end of the bolt, and then you just put it in. 3-jaw grabs onto the provisions that they made in the damper for this kind of tool, and then you screw that on, and it draws the damper out. Works really good. I have a couple of questions for the people that are here, and you guys let me know. I would also like an install tool, which I haven't found yet, and we would like to use one. And an install tool is really just simply a longer than factory bolt that has to be long enough with spacers to engage, like when you just put the damper back up after you've done your cam swap and swap the put the front cover and the timing assembly and the cam retaining plate and the front cover, put all that in place, and then put the damper on and just kind of have it, we just wiggle it on there just a little bit to hold it. And then what I have done for 99% of the LS things is WestTech had a very cool hydraulic, basically a press kind of. They have a tool that was a hydraulic damper installer and removal. I never use them to remove the LS stuff. They're very good on aftermarket, like ATI stuff, which they make fantastic stuff, because usually their setup is done for some sort of 3-bolt or 2-bolt assembly that you can screw this thing on, and then it just has a hydraulic ram that pushes against the snout of the crank, and then it just pushes the damper off, which is really reverse. You just you have to thread a long shaft that you thread in, and this thing slides on, and then you can press it back on. It works really well. You have to be careful with some of these things because the hydraulic mechanism, you plug air into it, but it's a hydraulic deal. It's strong enough that even if the damper is not going on correctly, it'll just peel material off of the crank. So you have to be careful. You have to make sure that it's right. And it has a pressure gauge that shows you, hey, look, you're at 10,000 PSI. Something's wrong. This is a warning. You need to fix whatever that thing is and not continually try to apply pressure. What you've done now is essentially kind of friction weld your stuff together. But I never have used that on the LS. But what I have done on the LS is the long shaft that they have those, because it has a threaded end to engage into a factory LS crank. I just made a spacer, and then what I do is I just screw the thing on, and it pushes the damper on, because it's this is all threaded, and because it's threaded on both ends. And so we just screw it on. I made the spacers. I actually made the spacers out of rectangular tubing. And then we have some, I think the things that on this rectangular tubing, that they don't work, they don't line up, and they don't engage the shoulder of the damper where the edge of the flat part of the bolt attaches to hold the damper in place. What I made doesn't engage in that. So I had to put effectively a spacer on the end of it, like a big washer. The big washer turned out to be pilot bushing. And so WestTech had pilot bushings for various applications, because they put pilot bushings on when we run them on the dyno, so that the snout of the drive for the dyno engages in that and keeps it all centered and stuff for the drive hub. So all that worked out good. So what I do is, using that assembly, I would screw it on. But what I would like to do is I would like to sell something that would help solve that problem for people that don't have this assembly that I've created, that I've made at WestTech, that I used all the, hundreds and hundreds of times. So what I need basically is just a longer than factory bolt with a shoulder or a spacer that could go on and engage this. And we could just, all you have to do is just screw this in. We always put, when we're doing something like this, when I'm using this assembly, when we're screwing it on, we always oil or anti-seize the threads so that when you're turning this thing on, you don't gall up the threads either on, in this case, on the nut or on that shaft. And the same thing for this bolt, this long through bolt. You just need to draw it in far enough where then you could use another factory bolt or an ARP bolt, which some guys put those on there as well. And then you could just tighten it on the rest of the way, because that's how we put them on. And I know that there are other ways to do it. And I know that a lot of guys don't want to reuse the factory bolt at all, let alone reusing it after they have tightened this damper on, you know, using it as their install tool, and then reuse that bolt. I can tell you that I've done that hundreds of times. We've reused the same bolt and reused it over and over and over again. And when we tighten it, we do the famous Matt Happel Ugga Dugga thing. We tighten it with an electric impact, and I usually it on 4 so that we know that it will come back off. And we're never putting them on so it's permanent. We're, so that it's going in a car and driving around. We're putting them on so that it's going to be taken back off, because we're going to do another camshaft swap, and that's part of the camshaft swap. So we've got to take it on and off. But it needs to go on tight enough where, because the factory dampeners, and this is the other thing that happens, the factory dampeners are essentially a press fit. And when we run blowers on them, we usually will use the drill and pin kit to pin them to stop the damper from moving. But when you take the damper on and off a whole bunch of times, it kind of wallers out the thing. And especially, I will add, and I have done this before, if you don't tighten the damper bolt all the way, or you forget to tighten the damper bolt, what happens is the damper will spin on the crank, and then it'll really make stuff wonky and wear it out. And then the damper doesn't want to have much of a press fit, if any at all. And then you're stuck to pinning it or tightening that bolt really, really tight. Either way, not great. But what I want to do is, and that's what I'm looking for now, is I'm going to look for a big hardened bolt or whatever that would just allow it. And something, again, I want something affordable. I don't want to make a custom bolt for that. I'm sure that there's something out there. So if you guys have seen that, let me know in the comments. But the other thing that I want to talk about, I got an interesting thing. In fact, I just saw the comment before I got on here. Is someone was asking about a turbo for actually a 4.3 or a 4.6 liter 2-valve Ford application. I'm like, well, and everybody's throwing these things out. Hey, should I use this, GTX 3584 RS on my 4.6 2-valve? And they were only wanting like, 500 or 600 horsepower. I'm like, yeah, you should use that turbo. In fact, you might be able to use our G3770. It would be even more responsive. But a 3584 on that 2-valve would be a good one. But people are telling them, oh, no, you need a 7875 or an S475 or what these things are. And they're like, oh, yeah, you're going to have too much back pressure. I'm like, no. on a 4.6 2-valve that makes 250 horsepower or something, it's not going to do that. It's not going to have back pressure. It doesn't have a lot of displacement. It doesn't make a lot of NA power. So it's going to be fine. That would be an ideal combination. In fact, you could argue that motor with that GTX 3584 RS turbo would be an even better combination than it is for a 4.8 or 5.3, because it's smaller. So, and if the guy wants response, he could get the 0.82 or 0.83 housing, depending on whether he wanted a T4 or a V band. I would personally go with the V band, but that would be a really good turbo for that. And in the power range that the guy's looking at, he doesn't have to worry about like excessive back pressure. Because the other thing that's not going to happen with this motor is that he's not going to be revving it. It's not a short runner 4-valve Cobra motor with cams in it, or a Coyote that he's going to run to 8,000. This thing is going to be lucky to see 6,000. So he doesn't run a lot of RPM, which back pressure tends to increase with RPM. So it would be a really, really good combination. So let me know in the comments what you guys think about what might be a good turbo for that. If you're a turbo guy and you understand how those things work. What else did we put up today? I'm trying to remember what the the post today was. We were talking about, because I've had some people, and I try to I try to be nice, and I try to a lot of times just wholly dismiss when some people make comments about things, and then try to also balance that with trying to educate them about things. And so one of the comments was that I got, might have even been an email. I might have been a message. They were asking about water cooled turbos, and I said, yeah, water cooled center sections are a good idea. They work. They said, okay, good, because I want to I want to cool the charge air. And I'm like, well, that's it's not going to do that. That's not going to happen. I said it'll cool the oil that you're using to to lubricate the shaft and the bearings for the turbo. I said, and it will keep your center section probably at a more realistic temperature, which is how it's cooling that oil. And so you don't have to worry about that hurting it. And it probably will help also with the longevity of the turbo, I think, for a long period of time. But I don't think you'll see much in the way of a change in charge temperature, because I don't think you could transfer the water temperature to the center section and then to the compressor housing. And then, because quite honestly, the compressor housing is probably already going to be cooler than the center section is anyway. So it would impart heat going in that direction anyway, because the air coming through the compressor is, you guys know how that's working out. But he did, and he didn't do the test, but a friend of his did the test. They said, well, we ran this thing, and we ran it at because we had a thermostat in there that was like a 200-degree thermostat. They said, yeah, we ran the water at like 200 or 205. We ran it on the dyno, and then we put a 180-degree thermostat on it, and we ran it at 180, and it made more power. So, and what their logic was that because we cooled the water and we cooled the center section, that meant cooler air from the turbo, and then that's why it made more power. And I'm like, well, that's a pretty big leap from what you're. I asked them, I said, do you have charge temperature measurements that show that? Do you have one that shows that, hey, look, the charge temperature? I said, first of all, and they said it was worth like, I know 15 or, yeah, it's worth 15 or 16 horsepower at the tire. I'm like, whoa. I said, do you know how much you'd have to cool the charge air if you didn't change the boost? That's a big assumption. How much you have to cool the charge air to make that much extra power at the same boost level? I said, so one thing is that if you did that test, I said, the boost probably changed. I said, but one thing, and if that didn't, if you had a wastegate and it was perfectly controlled and it made the 10 pounds or whatever that you were testing this at, I said, you made another change. I said, you didn't cool the water, or just cool the water going to the center section of the turbo in hoping that you would also cool the air. You cooled the water in the motor. I said, if you run the motor cooler, it will make more power, even if you didn't have a turbo on it. I said, that's definitely going to happen. If you run your motor at 200 and then run it at 180, you're going to pick up power. And I said, and the other thing that I don't know was another thing here. I said, and if that stopped you from getting in detonation where it was pulling timing, and now you have another extra degree or two of timing because of your coolant temp, based on what the strategy is for the factory ECU. I said, you could have more power from timing too. And the guy that I was talking to was really nice about it. He said, oh, I didn't know any of that. I said, yeah. I said, that's a big leap going from the cold to the center section, and then to the compressor housing, and then to adding colder air somehow that we don't have measurements for. I said, if you have some sort of factory ECU, I said, it might show you that if you have an air temperature gauge in this thing, it might show you a change in temperature. And if the boost was the same, I said, if the boost is the same, it's more than likely that your air temperature is going to be the same. I said, what you're talking about, the center section, I said, it's not going to vary at a measurable amount, I don't think. But 100%, if you cool the water, you're definitely going to make more power. And like I said, because of what you've done to the water temperature in the motor, it could have also then affected, because we have, the computer is sensing all of that stuff, and will definitely make other changes based on that. I said, so you got a whole bunch of different things going on there. Whole bunch. Okay, let's go back here. So, in honor of my post today on this. Ooh, nailed it. Okay, with a water-cooled center section, lower inlet air temps compared to a non-water-cooled center section. And we got our post up. Look at that. And we're winning. We're winning. We're winning. Okay, we'll get some. Move this up here like this, like how. Danny, specials, Dustin. Good evening. We'll buy. Let's see. We'll buy one as soon as it hits the website. I'm using a super cheap 3-jaw puller that keeps snapping bolts. What bolts is it breaking? Because we have this damper removal tool and we also have the valve spring tool, both of which a guy should have if he's doing like cam swaps, because it makes life so much easier to do it with tools that are just really quick and easy. I've had that style damper removal tool for several years. It works well. Yeah, I've used this type at Westech. I think they're from Blue Point or something like that. But it works really well. And as long as I've seen people break these tools, not because the tool is cheap or whatever, but because they're using an impact on them. And the fingers for the jaws, for the 3-jaw, they don't like that. They don't like it. And also, if you don't oil the threads, galling is a real concern about those that sort of abrupt take up on them. So I always do that by hand. And once you've freed it up, like the initial breakaway, because that can sometimes you can hear a pretty good pop when you first release it, when it first releases its hold, it snaps pretty good sometimes. And you don't want to do that with an impact. Once you loosen it up and it starts coming off, then an impact just to draw it out, probably fine. Works good. Yep. 3-jaw puller was on the website a few days ago, and as soon as I get paid, I'm purchasing one. Thank you very much. LS 3-jaw puller. I use the old dampering bolt and flex plate stop to put a new damper on the LS. Oh, to stop the motor from spinning? Is that what you're talking about? Yeah, you can do that. Works best with a bearing. A bearing would be good, yeah. I usually, when we're putting them on, I put oil on the surface for the damper, and then also on the pulleys or on the spacers that I have, which are the pilot bushings. Just use 10.9 all thread. Yeah, that would work. Did 140 degrees per manual. Never use a damper installer. I just tap it on with a hammer until I get the bolt started. Light pressure on the ratchet while tapping with a hammer. That's how you put an LS one on? I've put small block Chevys and small block Fords on with, at least we've started them with a piece of wood and a mallet. I just wonder if that's bad for the thrust bearing. How come commercials come on just when the information is important? Isn't that always the way? For an installer, you just need to thread a rod, washer, and a nut. Yep. Full topic of discussion. Anti-seize or bolt lubricant used other than preventing bolt seizure using is for torque, yield, strength. Have you been down that rabbit hole? I don't put anti-seize on like rod bolts and stuff, and I don't do that. I just use it on stuff that, like on spark plugs, and then on this, just if I didn't have oil or whatever, because it doesn't really matter which one I'm putting on there with the thing that we're doing. We just don't want it to gall, and I also don't put it in under enough duress to cause that problem. I stop before that happens because something else is wrong. If it doesn't just go on smoothly like we know that it should, then I stop and address the situation. When I was younger, I would not have done that. I would have, if it's not going on, we're going to apply more power. Richard, just got my boosted engine started up. Thoughts on eBay turbo manifolds, wastegate, etc. Looking to be a budget setup, but don't want to blow my stuff. The manifolds are hard to get wrong. The thing that you find with manifolds, like ours is going to be a casting, so you can't really hurt it. Some of the manifolds, the welds and stuff get to be problematic, and then they crack because the stuff is kind of thin anyways. The other thing that happens, I would say even more often than that, is some of these setups are not put on vehicles with all of the stuff that are on vehicles. So the fitment for stuff, you're like, hey, this is all great. I remember doing one for a Ford, and I'm like, well, they obviously never put this on a motor that has an oil filter on it, because the oil filter can't go on with this turbo kit on here. And so those are things to look for. Use all thread and toothpick washers, and a flat between the washers is easier. Richard did the chassis dyno on Friday on pump 93 E10, 321 wheel horsepower. Looser converter is faster and more mile an hour despite lower dyno numbers. Had a pump E85, saw 40% ethanol, picked up 7 horsepower and foot-pounds. Did you pick up most of the power down low? And then also Blue Collar did when you went to E85, did the timing change? Because with on E10 on 93, you at full temperature, you probably can't run full timing. But with the E85, you certainly can run full timing. For the DIY turbo kit you made with the GT45, what tools you recommend getting as a DIY, or maybe top 3? Well, for me to make that, we had to have a welder, and we had you have to have a chop saw or like a bandsaw or something to be able to cut and weld stuff. I just bought a balancer install tool off Summit, made by ACT Billet, $25. Haven't used it yet. Give it a review. Just a piece of threaded rod with a nut and a hardened washer. Oh, the installer tool. Okay. Yeah, I like the ICT Billet stuff. They do good stuff over there. I like the guys at Summit too. Measure with the yardstick, mark it with chalk, cut it with a torch. If it doesn't fit, get a bigger hammer. If it breaks, it needs to be fixed anyway. If it breaks, you just get an even bigger hammer, right? If some install tools for $5 to $10, that's the kind of thing that we're looking for. Remember old 283s and early 327s that didn't have the crank drilled for a bolt? What? I don't remember seeing one of those. Westech had a couple of. I've never seen one on a 327. I guess they could have had it on 283s. Westech had a couple 283s, but I thought that they had bolts in them. Of course, I haven't seen that many. I've only seen 2 or 3 that have been at Westech. I want to see you Amazon Turbo a Ford 6.2 from a junkyard. The problem with that is I've never seen one. I meant a flat bearing between the washer. It makes it easier. Yeah. Yeah, like a roller bearing. My car's been in this guy's shop for a year to get ported heads, but internals, should I be worried? It shouldn't take that long to do any of that. That's a couple of days. Richard, I have a question. I have a 4.8 Gen 4 for my drag car. I'm looking to do 800 wheel horsepower. What size turbo would you recommend, or what turbo setup would you use? You should put one of our G42 turbos on there if you're going to try to do 800 wheel horsepower. That would be good for that. You're going to need, I don't know what your drag car is, but on a 4.8, you're definitely going to want a converter, and you're probably going to want to run more engine speed than you would on some of the bigger motors. But our low butt truck cam and a G42 and a 4.8 will do way over 800 wheel horsepower. Good evening, Richard. I have a 2019 6-liter LS out of a GMC Savannah. I want to make 550 to 600, and then down the road 900 or 800 with a turbo would be a good camshaft to start off with. Is that the 6 liters that they continued into the in that Savannah? Is that the heavy duty 6-liter thing that they continued where they didn't put LTs in those? Because otherwise a 2019 obviously would be an LT. If you have that, you're going to not make you're not going to make 600 NA horsepower. And the good news is that you don't need to if you're going to put a turbo on it later on. 600 horsepower out of a 6-liter would take a lot of money. It would take some of the best ported heads, a good, really, really good intake manifold, and a very, very big cam. And it would take a cam that you don't later want to use with a turbo. So put like our Truck Plus cam or something like that, or a BTR hot rod cam or something like that. And don't worry that you didn't make 600 horsepower, because when you put the turbo on, you'll make as much power as you want. And then also you'll have better boost response. I'm doing a Slop Mechanics stage 2 and springs. Garcia, let's see what your thing was. Uh-oh, what's going on here? Scrolling. I don't see your other stuff, Garcia. Richard, this is off topic. And for everybody, there's no off topic. If you want to ask about Bigfoot or Chevy Sprint turbos or whatever you want, all of that's fine. Any sort of question is fine. So let's see what your idea is, or let's see what your question is. Do you replace rod bolts when you pull internals for ring gap? I don't. I reuse the factory bolts. On all of the Big Bang motors, those are all stock bolts. They're stock original bolts. 4.6 to 4.8 is the ideal size for a GTX 3584. 0.82 AR would definitely water cool. Ball bearing turbo journal bearings have more oil cooling. Are you saying that you would definitely use a ball bearing turbo and that you would water cool it? I don't know why you're going to that for a 4.62 valve. They're not going to want I mean, that's going to more than double the price of the turbo, so they're not going to do that. Richard, weird question. LS3 12-to-1 compression revving to 8,000 B-charge Trinity intake manifold. What's a good way to help limit torque but still make more power? Well, you've already done all of that. If you're wanting to make power at 8,000 RPM, you're going to limit torque because you're doing that, because you put a big camshaft in it and you put a short runner intake manifold on it. It's definitely going to reduce torque. And if it's an LS3, it's a rec port head, so you're going to reduce torque already. You've already done all that. And then if you need to, and you want to reduce torque even further in some RPM range, you could do that with timing curve. Oh, the recommendation for the guy that was asking about 1 year taking that time, make sure all of your stuff is still there. That's important. Scrolling. Man, got a long ways to go. My comment on that post is already etched in stone. A really important question. I hope you can answer. I hope so. It's a tiny 5/16 bolt. The factory rod bolts are fine on an LS. You won't break the rod bolts. You'll break the rod. You'll break a factory rod before you break a rod bolt. So you don't worry about those. Friction welding the engine bay must be interesting. I've got a 383 LS I put together a year ago. It makes 386 at the wheels. You think adding a turbo just on one side would be cool? Yeah, I already have videos up on that, and you can try that if you want. Currently trying to build a drift truck and have a Gen 3 4.8 VORTECH. Would you consider that a good engine? Yes, those are all good. That short today was from November of last year. Richard, do you think I would be able to change the main bearings on my L94 without removing the front balancer? It's on an engine stand. I'm trying to remember if the front cover is going to overhang that. I can't remember now. I think you're going to have trouble with the front, and you might have trouble with the back too. But it's really easy to take the damper off, especially if the motor's out and it's on a stand. I have a Fox with a stock bottom end 302, GT40Ps, trick flow, stage 1, Track burner, which GTX 34 should I get? 82 or 121. I don't race my car just for fun. Well, what kind of power are you trying to make? Are you trying to, like, that's probably going to make, I don't know, 330 or 340 or something like that at the flywheel. So are you trying to add like 100 or 200 horsepower or something like that? Either one of them will work. I think I would get a 121 because it's going to be more than, on that torquey thing, it's going to be more than responsive. Low timing will superheat the exhaust manifold and cause cracking. Don't know the pullers were already on the website, just ordered. My low buck truck cam lifters set should be here really soon. My 09 VORTECH Max will be getting the truck plus cam. I'm sitting in the room. Very cool. Does anybody know what the thread pitch is on the crankshaft dampener in the LS? I don't remember what the thread is. Richard, timing did change. It's high, in my opinion. I previously saw 27 to 28 on 93. The tuner has it hitting 31 on E85. Yeah, I've never seen a LS respond to that much timing, especially fuel injected like that. And I'm surprised that you could get 28 degrees on 93. That would surprise me at temperature. I have a 4.8 Gen 4 motor. I've got a Gen 453 rotating assembly. Should I use the 4.8 pistons for compression? Yeah, you're going to have to rebalance it after you do that. I've been thinking getting rid of my stock balancer. Well, are you talking about replacing your stock balancer with something else? Shadow says it's an M16 by 2. Thanks. I'll definitely get that ordered up. Going in a Fox body. Yeah, that's good. 6-liter and UPS ammo that's on vans are still port injected. Yeah, I know that they carried the 6-liter on later in they were doing it because they had some issues with the direct injected stuff being problematic in some of the heavy duty chassis. And so they continued the Gen 4 motor for quite a while into the after starting the run of LT stuff. It's been hot here. 83 Thursday and Friday, 80 Saturday, 78. Cold front coming in. Blue collar, where are you at? Are you in Florida? L96 is the last 6-liter. Yep. Richard, I'm looking to buy this LS1 from a guy. It has a stage 4 truck cam. Heads have been reworked. I think they're 823s. There won't be 823s on an LS1. An 823 would be a rec port head. And I have a Trailblazer SS intake manifold and shorties. How much wheel horsepower can you know what heads are on there? They're not 823s. They're something else. And I don't know which stage 4 truck cam you have. Is it a BTR one? Whose is it? The newest ones are 6.6. Richard, it was hard to tell where I gained the most. Unfortunately, it's hard to control converter flash, 7 horsepower, 7 gold. It rained in Sugar Land, Texas. A cool front came through. I changed the oil in my truck. Nice. What is my favorite tool? Is that what your question is? I'm considering sending my 241 heads to TSP for CNC porting and a valve job. Is it worth it to grab some 243s instead from the junkyard to have them to do 2? Are they superior? Once they're ported, you can get, even with a ported 241 head, their program should be able to get more airflow than you're going to be able to use on your combination. I've seen ported 241 heads that go over 300 CFM. So you're very doubtful that you're going to be making 600 NA horsepower. It's a non-DOD 9.7 to 1, changing from the rec port heads to the 799 heads. How come you're doing that? Do diaphragm clutches still stick to the floor at high RPM? Has anybody used a diaphragm clutch in a long time? What torque specs do you use for the reused rod and main bolts? We use the factory specs, which is a initial torque setting on the rods, if I remember right, it's 15, and depending on whether it's a Gen 3 or Gen 4, I think the Gen 3 is 60 degrees after that. It's a angle torque after that, and then the Gen 4s are 80. Is there 50 weight oil DDP in it? Just curious. I know it plugs cats up. Does Rotella have something like that? When did GM actually start using the floating pin in the Gen 3 trucks? They did it during the intermediate term between the Gen 3 and the Gen 4 stuff. So they have Gen 3.5 stuff. But I don't know that there's a good way to know that other than people have found those, because they probably phase them in during assembly line procedure. Ball bearing turbo should have water cooled because the oil restrictor journal bearings have more oil cooling effect. Okay, I see what you're talking about. Why are you getting rid of the rec port heads and going to 799s? M16x2 is the crank bolt. Orlando, Florida. Okay. It's stock balancer for something aftermarket. What's your opinion and recommendation? We have broken stock dampers. All of the ones that we've broken have been truck ones. We've never broken any of the tight offset. We've never broken any of the Corvette ones. None of those. So replacing a truck damper, I think, especially a high mileage one, probably a good idea. And then pinning it, also a good idea. Rev at 6,700 on the engine. That being said, we've run and I probably shouldn't be doing this, but we've run the 5.3, the L33 to 7,800 a whole bunch with a truck damper on it. That's probably not a good idea. Have you heard of Redline camshafts? I'm thinking about putting one in an 86 Toyota. I have not. BTR stage 4 truck cam. I'm not sure what heads are on it. I'm hoping to get 350 wheel horsepower out of it, being an LS1. I think that's doable. Yeah, I don't think that should be a problem. A cammed LS1, I don't see any reason why you aren't there. And if you have any kind of head intake you have, I'm hoping that you don't have an early LS1, that you have an LS6 intake manifold on it. Then I don't think 350 is going to be hard at all. Changing from the port heads to the 799 heads because I bought my fuel system with the intake, everything before I got a 6-liter. Originally thought I was building a 5.3. But rec port heads you can't use on a 5.3 either, so I'm still confused. On a Fox 302, what is the response difference between an 8.2 and a 121? I'm more convinced with quick spool rather than overall spool. Is this in an automatic or a stick? And you're not, the trade-off isn't going to be overall power. I've come and just said GM heads, and I don't believe bow tie 49 aluminum heads. Not much information on them. I don't know that part number, so I don't know what head that is. On Rotella oil, the API codes must specify SM, SNSP on it. Gas engine cert. I know, but I thought all of the sloppy guys were using it. I thought that was the go-to. Mine is STP on sale oil, whatever that is at the local AutoZone. At the AutoZone. I see Matthew has purchased a damper puller. Thank you very much for your support. It's a stick shift. Okay, that's fine. You won't be able to tell the difference between the two, and I would recommend the 121, but you are welcome to order the 8.2 or 8.3. Suzuki Samurai 0.82 GT3582 is incredible on the manual 5-liter Fox body Mustang. Circa 2004. My bolt-on automatic Z28 made 346 wheel horsepower, so a cam better be a lot more than 350. Intake as a cathedral port intake because I thought it was going to build the 5.3, and then the 6-liter fell on my lap. I think BTR hot rod cam is the best to go with. For what are you trying? Like, okay, I'm confused now. What motor do you have, and then how much power are you trying to make, and then what are you trying to do with it? Like, you're trying to drag race it as a daily driver, and then I'll give you a cam recommendation. Did you ever run an ASA cam? I have not run an. My truck has seen 7,400. Should I get a damper for it? I don't know. Like I said, we've broken them, and I don't know if it's something we did. I don't know if it's something that happened at the wrecking yards before I got the motor, because they obviously weren't new motors. Would you up the rev limiter any 5.3 truck Norris cam with springs and ring gap? Seems happy. Haven't put the turbo on it yet. Crazy foot. Where are you revving it now? Yeah, if you have a stock truck intake manifold on there, it's not making power pass there anyways. They are, from what I could find, over-the-counter aluminum heads that GM sold in the 90s, 55cc combustion chambers. Are they? They must be small block Chevy heads then. Are they the They're not the L98 heads, are they? Richard, I have a 454 with like 8-to-1, 230 intake port, oval, 214, 218 cam, long tubes, 871 blower, 10 pounds. How much horsepower you guesstimate it's making? 8-to-1, 230. I don't know. Let's say that's 400 or something. With a 214 cam, yeah, that's probably going to be 400 or something, or less than that. 10 pounds. I don't know. 100, 650, something like that. Love all the content. Thank you for watching. It's the 2019 6-liter. It's going to be drag race weekend warrior. Okay. Okay. So if it's 6-liter, put a big cam in it. Put like a BTR. If you want to make a lot of power and you're going to drag race it, put a BTR stage 4 LS3 camshaft. We can get those because we're a BTR dealer, so we know which one to get. You would get that cam. You would get their 660 or 650. I think they're 660 lift springs, and then probably going to want an LS3 intake manifold or the truck rec port intake manifold is good. Don't put 799s on it. Keep rec ports on it. It will make more power. What injectors you usually run for your LS3 turbo NA builds? So we select our turbos. I mean, we select our injectors based on whatever the power output is. So we put injectors in there that are big enough to feed the power output that we're trying to make, or that we will end up making during testing. So normally we would either run 80s or our 1000cc injectors. Now Jimmy is doing testing right now, I think, with some... I've also run 1500s from Snake Eaters, but Jimmy is testing some 2000s or some 2200s that we might offer for guys wanting to do bigger stuff. I'm from Jamaica, and we don't have access to machine shops that balance rotating assemblies. If I do a built short block K24 H23, would 8500 to 9000 be dangerous without balancing? Yes. 9000 is beyond a factory motor anyways. Even if it was balanced, 9,000 would be a lot on a K24. And you don't need to rev it that high to make lots of power. Might you try overbalancing an LS engine on the dyno and see if it vibrates less at high RPM? Explain to me overbalancing. Isn't there just balanced or not balanced? Smallback Chevy, yes, but not L98 heads. I'm planning on using them with a 268 cam dual plane, a stock bottom end in my truck, hoping for 400 horsepower and 450 foot-pounds. Trying to think, the 400. Yeah, you might get. I mean, I don't know. You're not going to get there. I doubt you'll get 400 horsepower with that camshaft. I mean, you might if the heads are really good. Is this going to be a dual plane intake manifold and a 750 carburetor or something? Think you could... Are you saying add weight at the dampener to overbalance on the stand? Yeah, I don't know what that's referring to. Would a water-cooled center section lower inlet air temps compared to non-water-cooled center section? 53% are saying no, 47% are saying yes. But it would sound awesome at 9,000. They do sound really good. I mean, Jimmy is running his... he's running his an F series, but he's running his at 8,500 or 9,000, I think. And we ran my K24 1000 on the engine dyno, but I don't know how long it will last like that, because we didn't do anything to the balance shaft, and we didn't do anything to the oil pump. Both of things were that we should have done when we were doing that. They're different profiles. 232. They have two different profiles: 430 lift, 110, 230 duration, or 425 lift. Those are dramatically different camshafts. I mean, you're talking about 14 degrees difference in duration, and this is on a little Toyota motor. I think we think that would be a lot. 96 went from 2010 to 17. That was my question about the 19. Overbalance is adding a percentage of the rotating weight to the bob weight. 1 to 4% extra weight. So, but if you're adding weight, aren't you then making it no longer balanced? I guess maybe I don't understand balancing the way that I should. And you'd have to overbalance worked on our Talladega motor. So how do you know to compare it to something else that you, because comparing a balance versus an overbalance thing is a really difficult proposition doing a back-to-back test on something like that. 750 carb, dual plane manifold, all the regular street stuff. Wondering if you might know a better cam if you don't like the XE. I love the XE268. I think it's a great like street cam. I just don't know that it's a 400 horsepower cam. But maybe. Your compressor temp would change dramatically with boost. I don't see how you get enough heat transfer across the shaft and housing to measure. Oh, are you talking about on the water cooled center section? Yeah. Yeah, I don't know. I don't know how you test that. I don't. That's like doing. I mean, that's even. I would think that's even worse or even more potentially problematic. And for no gains. I mean, I don't see how you would get gains. I don't see how you would measure it, first of all, and I don't see if you could measure it. I don't see how you get gains, because changing the weight is gonna the only gain I would think you'd get would be from changing like the weight of the reciprocating assembly, like we did, but we did moment of inertia changes from the back on a big flywheel, which is a lot. But if you change the weight of the crank, it's not. That's like in the center of the spinny part. That's not very much. The remain was fretting or bouncing around when we were overbalanced. So it cured a vibration, right? It cured a harmonics thing, right? But not a balance thing. The dyno floor didn't shake. Okay. Yeah, that's at a level beyond what I've done. 29 Silverados, all LT engines. That's what I thought. I didn't think they went that far, but I didn't know on the 6-liter stuff, because none of the LT stuff would be 6-liter. Those would all be 6.2s or a 5.3 or an L83. If you guys, Mike, if you guys did that test, did you ever measure? I mean, it sounds like you had a program. So did you guys run the two different things that you did on the dyno and see if they made any power? I'm going to stick with normal balance and let NASCAR do their thing. Yeah, that's not the level that I'm at. 2019 6-liter 2500. I won in my 13 Tahoe boosted. Okay. Yeah, I just don't know. Let's see. Let's go to here. Here's where we'll find out. The ultimate guide. No, not Chevy trucks. We want to do to on all cylinders. L96. Brian and the boys did a good job over there. It says 2010 to 17. But is there a different one? Thought I might want to try it. I'm not interested in running a cup motor on the dyno. But Westech guys have run some older ones. Baby boosted torque storm, air to water. Shirt path was night and day. Heavy Chevys? What are you trying to say? Use your words. Short. Okay. Short. What do you mean short path? I don't know what you're talking about. We didn't have tech back in. Okay. You didn't have dynos back in the 80s to run one of the motors the one way and the other motor that you fixed? Only 2,500 trucks got it in 2019 Express fans. Okay. I'm comparing two different cams. Intake duration and intake exhaust lift are the same. Exhaust duration is 8 degrees larger on one and 3 degrees LSA more. Is this pedantics? No, those are different cams. One with 8 degrees more and a 3-degree change in LSA is going to have a different power curve, especially if one cam has both of those. The Corvette engines were hot balanced on the flywheel and the balancer. So I'm planning on running a low buck truck cam with a turbo in my LH853. Aside from gapping rings and running head studs, what else would you recommend? You're making sure that the deck surfaces are prepped with the right RA number for MLS head gaskets. It's the factory one, so it's not going to be a problem. You have to make sure that you have the right pump and injectors for your application, and then obviously it's tuned right. Small pins were placed in the flywheel. Trial by error. So you guys are figuring out carrying some sort of harmonics thing, huh? It's an interesting way to do it with putting pins in. I've never heard of that. Valve springs, maybe. Yeah, with the low buck truck cam. My wife has a GMC Savannah RV conversion. Has no trouble getting up to speed. Put good engines in them. The Savannah. Life on the Savannah can be tough. Water cooled. We're getting closer to 50-50. We got 51 yes and 49 no. It's all changed. The answer is no. Just in case you guys were wondering. We'll go ahead and end our poll there. That's 50. Yeah, it's 50-50. The blower's on the passenger side. The water to air intercooler is connected to the blower and right back to the throttle body. Big difference. Get about 9 psi. 6.0. The truck Norris headers. So the blower's on the passenger side. That's pretty normal. Air to water intercooler is connected to the blower, to the discharge, and then right back into the throttle body. There's a big difference in what? What are you saying is different? Redline camshafts are ground by EPN. Said high torque for 4x4s. Add 8 degrees of duration and 25 thousandths left over stock. Are they regrind camshafts? 496 or 315s, Magnum, 6-speed, tire burner, play toy. What intake do you use? What in your 496? With a 6-speed trans, you're not going to have trouble spinning the tires with a single plane on it. But, I mean, you should put a tunnel ram on it and have it stick out of the hood. Very rarely do I recommend a dual plane. Repeat, lagged out. I have some Corvette flywheel and some pins driven in. Genuine factory luck flywheels. Okay. I mean, I've seen them like externally balanced stuff have that. You know, an externally balanced damper or externally balanced flywheel, one or the other of those, or sometimes both of those, depending on what engine family it is. Why are vans built so good? Well, you want that to be the case, right? Does porting without a valve job yield good gains on a motor with a fairly efficient head casting? I don't know what you mean by that. I don't know what you mean by a fairly efficient head casting. What head specifically are you talking about? And usually the valve job and also the valve seat has to be tapered to the valve job to get best results. You can do porting and get more airflow from porting, but every really good porting job includes a valve job and seat work. Everything power and air temps. I'm in El Paso, Texas, and it's hot. Totally different truck with that setup. Was only seeing 5-ish PSI from the torque storm. You're only seeing 5 PSI with what kind of combination before that? Because even if you had a longer front mounted intercooler or whatever, you shouldn't lose much boost at all. The hot balance was to smooth out idle quality. LQ4 with flat tops, 243 heads, Trailblazer SS, thinking Chupacabra, hot rod C10 pickup. Yeah, no, that's a good choice. That's a good cam. The Chupacabra, Truck Norris, our own Lowbuck truck, which is again on back order, unfortunately, because they sell out really fast. But all of those are fine. All of those you'll like. I've never had anybody complain about the combination of power and torque and chop and drivability and stuff. Is swapping rec ports on LQ4 as simple as swapping heads and intake manifold? Yes. The rec port heads are also going to require the rec port rockers. But yeah, the heads and intake go together. Because the rockers on a rec port have, you can use the same exhaust. Although somebody recently told me that the exhaust is different too. And I don't know if I buy that because I've never ran a different exhaust rocker on there. But it's an offset rocker for the rec port head. So you have to have the offset rocker also. So if you're getting heads, hopefully they have rockers on them. And then the rocker stands are different on the rec port heads too because of the offset rocker. But it's worth a pretty good bit of power. And the nice thing, it's both good and bad. The 317 heads that you had on there have a big chamber on them. The rec port heads that you're putting on there also have a big chamber on there, near 70 cc's or 69 cc's, somewhere in that range. And so you're not going to change the compression very much. If you put 799s or 706s on there, you change the compression, but those heads don't flow as well as the rec port head does. What happened to the mushroom lifters? Yeah. Do they even, are there even suppliers for those anymore? Because wouldn't those only be like real class specific stuff? What are your thoughts on titanium retainers versus steel ones as far as longevity goes? For what application? The vast majority of people who use titanium retainers are not doing it for longevity. On an LS, I wouldn't put titanium retainers on it. It's not necessary. Because the steel retainers are so small that the gain that you would get from like the weight change that you get from titanium retainers on an LS application is just not very much. And Brian Tooley showed me Spintron stuff that shows that the steel stuff might just be better. Say like an F20C that has a really good porting without altering the factory seat angles, but I understand doing valve seat works. Yeah, it yields better gains. On an F20, I wouldn't port the head. I would just leave it alone. If you're going to do it, just do very, very minor bowl work. Don't try to make it bigger. It's fairly thin in a lot of areas, and the gains are not going to be great. Have you run a 6-liter with low buck truck? What do we make? Yeah, the low buck truck gains like 60 horsepower on a 6-liter. Torque Storm changed the covers now, but a lot of people are seeing 5 psi. Had a few come in just for a tune correction because they blame their tuner. We're at 3,700 feet. So I still don't understand what the comparison is. You said it's much more responsive or making more boost or whatever. Did you change to the new Torque Storm? I thought your comment was that you changed to a position of the intercooler or the length of the discharge tube or something like that. If you did change the length of the tube, what are we comparing that shorter length to? Did you have a big front mount or whatever? I'm just trying to get a feel for what you were comparing. I thought you were talking about the mushroom lifters for when they ran the flat tappet stuff. Well, Dan, why are you chiming in here on this NASCAR-y stuff? Got 1 more minute. I'm doing a refresh on 22R, new molly rings converted to double roller tire. Smooth out the ports, new flywheel bearings, head bolts, ball hone cylinders, and valve job. So I'd put the milder of the 2 cams on that. How much horsepower is a full 2.5-inch exhaust good for before it becomes necessary to go up to a 3-inch? There is no like fixed amount where, oh, you got to go to a 3-inch now. Because what happens is the more and more power the motor makes, the more restrictive the exhaust becomes. It still runs and it still makes power. It's just that you start losing more and more power as you go up. I think the test that we did on the exhaust test that I have the video up on, I want to say that was like a sub 600 horsepower motor. What boost gauge do you like? I don't know. I put a digital one on the Omni, and I'm not thrilled with it. I would actually like an analog gauge. Autometer has good stuff. How do you feel pairing a Choppa copper cam with a G42 and a 6-liter? Still trying to make my mind up, looking for response and plan on running a higher than factory stall. You won't need to do that on a Choppa copper cam on a 6-liter. You can. A converter always helps. If I was going to run a converter, I'd run a bigger cam than that. Because if you're going to put a 2800 stall in there, and the G42 on a 6-liter is going to be fantastic. We have a G42 with a Truck Plus cam on a 5.3 in the Tahoe, and it worked fantastic. And now we have the Truck Plus with a 3584, and it's really amazing. I appreciate you provided a platform we can ask these questions. Happy to help, man. Change to air to water. Went from front mounted to quick watered air where intake tube would be. Short distance versus front mount. Tried 3 different front mounts. Okay. Close shift is the one that was junk for me. Yeah, there's a lot of really, really inexpensive ones that are out there. And the one that I got is that. I just ordered the like cheapest one that I could find because we just kind of wanted to do a video on it. The problem I have, it works. And I don't like that the plugs are so big, getting them through, some sort of firewall, which you have to get it through the firewall to mount the gauge. And then versus it has a little map sensor and stuff that you mount, which I don't think that's necessary. I'm old school, and I just like an analog gauge with a rubber hose that you plug into a barb fitting on the back of the thing to read the boost. That's all fine for me, but this digital one also works. But the trying to see the digital gauge and certainly trying to film it is a problem with a digital readout and then a camera because, they get synced up and it just flashes. But even trying to read it when it's, bright out and the angle of the sun is at a cattywampus angle relative to the display screen. And so you just can't really see it very well. So at night you can see it good when you shouldn't be racing around anyways. But, so the digital thing is a little suspect. On small valve LS, would larger exhaust valve help any? Larger valves themselves help on the small valve stuff. If you take a 706 head and port it and put bigger valves in it, it becomes a better head. That's what all of the really good ported 706 and 862 stuff, like the ones that I tested from BTR. But everybody has those. I mean, everybody has programs now. It's been a couple of decades now. Everybody has programs for those heads. And so you can make them flow a lot, but when they get 300, or 300 plus CFM out of them, it's always with bigger intake and exhaust valves. But they don't normally go just bigger on the exhaust valve. Can't wait to get my G42. I know you'll like it. It's good. Heard about people swapping an 8-speed ZF trans behind LS engines recently. Have you looked into that? We are looking into that. Jimmy wants to put the 8-speed automatic behind his that F series in his S2000. And so it would be cool. It's annoying to have to do conversion math from PSI to inches on boost gauges. Yeah. I only like PSI. And then on the other side of that is I like the vacuum to read in inches. And I don't like gauges that only read boost. I want to see the vacuum too, because you spend most of your time driving around like that. In fact, I put a boost gauge in my car in my in the Civic, in the VX that I had that Chad now has. I put a boost gauge in it, just using it solely as a vacuum gauge, because we wanted to keep it. You keep it at a certain vacuum range to keep it into lean burn mode. Have a great night, Drag Van. Thanks for showing up. And on that note, it is time to go. Thank you guys all for showing up. And I hope you guys had a good weekend. I will be back tomorrow.